All right, I think we live everywhere. What's up, everybody? It's KG.codes, Kelvin, and I'm back for another coding challenge. It's a medium one. This one should be different than the ones I did before. But yeah, I'm about to go ahead and try to do this coding challenge called Keys and Rooms. Try to do these every Friday. I ain't fell off too bad. I missed 1 week, so I'm back again for this week. And yeah, hope y'all can join and help me go through this coding challenge or watch me go through it. I just did it. I'm not going to lie, but I'm going to do it again from memory. I'm going to try to go through it, explain what I'm doing, go through the problem, troubleshoot any issues I have with the code, and just try to solve this problem just based off memory. Hopefully I can do it with no issues. But we'll see how it goes. I'm sure I have people on here eventually to help me. So yeah, let's go ahead and get started with it then. This is called Keys and Rooms from KG.codes. It's a medium problem, so a little bit harder than usual. There are n rooms labeled from 0 to n-1, and all the rooms are locked except for room 0. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock other rooms. Given an array of rooms where rooms I is a set of keys that you obtain if you visit room I, return true, and if you can visit all the rooms, return true, and otherwise just return false. So in this example, they have this list of rooms, array of rooms, and then it has these subarrays with the keys in each room. So like this is 4 rooms. In room 1, you got 1 key. In room 2, you got the key 2. In room 3, you got the key 3. And then in this room, you have no keys. And they say here the rooms are labeled 0 to n-1. So actually, this is room 0 that has key 1. Room 1 has key 2, room 2 has key 3, and room 3 has no keys in it. And so basically they just saying like this door is unlocked to the first room. And so you can pick up a key in every room you go to. And so here we pick up key 1. So then and they give you like the explanation down here, but you go to the first room first, you pick up the first key, then that means you can go to door number 2 or room number 2. Room number 1, which is this one. Then you pick up key number 2. That means you can go to door number 2 and you pick up key 3. And then you can visit room number 3 and you have no keys. And since you are able to visit every room, all 4 rooms, then you return true. And in this case, you cannot enter room 2 but since the only key that unlocks it is in that room. So if you see here, if this is room 0, this is room 1, this is room 2, and this is room 3, then you see that the only place that has the key for room 2 is room 2. So basically the key for that room is locked in that room. And so in that case, you need to return false. Or if any other case that you can't get into all the different rooms with all the different keys, you need to return false. So I hope that makes sense. Basically, this keys and rooms problem, basically they give you a bunch of rooms with keys in them. And you need to figure out if you can go through every room and get the keys out the rooms, unlock the door to each room. And if you can get to every single room with the keys that you pick up, then you return true. It's kind of like a little game. So I kind of like this problem. I probably wouldn't like it if I was in the interview, but I like it, because I'm just playing around. And you know what? I ain't playing. I'm trying to learn stuff here. So it is what it is. But it's a cool little interesting problem for sure. So yeah, let's try to go through it and see how to solve this. So when you think about how to solve this, like how I like to do it is think about how I would solve it in my head and then try to take that solution and apply it to code and apply it to like the data structures and algorithms that I know in my mind. And so try to translate that to data structures and algorithms. So when I'm looking at this, I know that they're telling me I can start with room 0 because it's unlocked. So I know I got to start at room 0. So then when I start at room 0, so in this case, room 0 is this first one with key 1. I know I can pick up that key. And then whatever keys I have, I know I can go to the next room with those keys. I can't go to a room I don't have a key to. And so in this case, if I know I can start with room 0, I'll go here. I'll pick up the key, and then I'll go to room 1 with the key for room 1, which is here. And then I'll pick up key 2, and then I'll take that key and go to the next room. So then I'll go to room 2 that has key 3 in it. Pick up key 3, go to room 3. And so basically whatever keys, and in this case, if I have like 3 keys, I need to go to every room that I have a key for if I haven't been to that room before. So in this case, if I got to start with room 0, right? So I got to start with the first room because that's the only room that's unlocked. I start with that room. I get key 1 and 3. I know that first I'm going to try to go to room 1. Room 1 is here. And then next I'm going to try to go to room 3. And room 3 is here. And so when I go to room 1, I'm going to find 3 keys. 3. So then I haven't been to 3. So I'm going to go to 3. Test that out. Then I'm going to go to 0. But I've already been to 0. So I don't need to go there. And then go to 1. I already been to 1 because I'm in 1. I already have a key for 1. So I don't need to go there again. And so basically I need to have a memory of places I've already opened the door to. And so how do you do something like this? Like, how do you loop through or traverse like a matrix type of thing? When you're practicing these problems, if you learn the foundations first using like Algo Expert or Algo Monster or some sort of tool, it'll teach you techniques of how to traverse certain data structures and algorithms. And it'll teach you the data structures and algorithms first. And here, whenever you have a array of arrays, it's typically going to be like a matrix problem or a grid problem. And so when you have matrix and grid problems, then you can kind of narrow your tool set to what kind of solutions you have. And the first thing I thought of when I did this, I said, okay, I got a matrix problem here. I know I need to traverse a matrix. There are multiple ways to traverse a matrix. One of the ways that a lot of big companies asked when I was doing interviews is using breadth first search to search the matrix. And so I know here, every time I get to a room, I can have 1 or more keys. I can have 0 or more keys. And I know from those keys, I need to use those keys to search more rooms. Whatever those keys are, I need to take those keys and search the other rooms. So I know if I do that in the mindset of a grid, like if I get to a place in a grid and I need to search everything around it, I need to kind of take that collection of things I found and then go and search in those directions. I wouldn't say recursively, but I just need to be able to keep track of, the next thing that I need to search, which in this case is keys. And then how you can do that is breadth first search. Now, if you've never done that breadth first search before with the grid, then you're going to learn today. It's something that you just got to kind of get used to and get to perform to memory. And then when you see problems like this, it'll start to like pop up in your head like, dang, maybe that's the solution. The other important part here is I don't need to search a room I already been to, because then I can get stuck in the infinite loop. Like here, you can see if it's telling me to go to 1 here, then I go to room 1. I go to room 1 and I got another key for room 1. Then I can just keep getting stuck in a loop of just keep going to the same room. So I need to also keep track of if I've already been to a room and I don't need to enter that room again. So I hope that kind of makes sense. I think it'll make more sense once we start jumping into the code. For anybody that's just joining, the problem is keys and rooms. Basically, you get rooms in an array, and then you get these subarrays that have keys to the next room. And the rooms are ordered 0 through, whatever the number of rooms is. So this is 0, 1, 2, 3. And then you get these keys, and you need to try to move through the rooms to see if you can get through all the rooms. If you can get through all the rooms without getting like stuck where you don't have a key to get to all the rooms. And then there's some constraints down here. So if you're in an interview, they may ask They may have the constraints or they may not. You may have to ask for them. So this is one thing when you do these problems, you get used to kind of like thinking about like, what if, can I do this? Can I do that? The one thing I'm thinking about here, they say it here, the room will have distinct keys in it. So the keys will never be the same in a room, but they can be the same across different rooms, which I wish they would have said that up here, but they didn't. But down here in the constraints, they basically telling you, okay, the room length equals n. They're just giving you kind of definition here. And they're saying that you'll always have at least 2 rooms. So we know we'll have at least 2 rooms. So we don't have to kind of try to account for like 1 room or 0 rooms. And it's going to be less than 1,000, which is manageable in some sort of code. You're not going to have any kind of like crazy issues with the code. And then we have the room length. This is room I. So this is the keys in that room. So this is like if I had this room, I have 3, 0, and 1 keys. So in these keys, it's basically saying there's less than or equal to 1,000 keys in a room, which is manageable in code. And they're saying all the I guess the sum of the length of the keys, the sum of the length of each room's keys is 3,000. So I guess there's no more than 3,000. I don't understand this one. Maybe somebody can give me I don't know. I guess it's like the sum of all of them is less than 3,000. So I guess there's less than 1,000, and then the sum of, how can you have the sum of the length? I don't get that. Anyway, it's just one thing. So what's the sum of just this one thing? Oh, I guess all the eyes, the lengths, the sum of all the lengths together. Okay, the sum of all the lengths together is, so there's no more than 3,000 keys. Period. Okay, that makes sense. And then there's less than 1,000 in per room. Yeah, see, that's confusing constraints, man, to me. And then this is important. No single key. This is in a room. The keys in each room. This is why you kind of have to know how to do a matrix, like what is it? 2-dimensional matrix. You got to know how to do it, because this is how you access it in code. Is you're looking like in a row, and then you're looking in a column inside of a row, basically. In this case, it's like a 2-dimensional array. So you have each room, and then you have these sub arrays that represent the keys in the room. All the values in a room, all the values of rooms are unique. So yeah, that just means the keys in each room is a unique key. So important constraints to know. It's a lot of constraints here. I mean, I guess it's a medium problem, so it's a little bit more, but we'll just have to keep these in mind. So without further ado, let's jump over to the code and start trying to code it out. So we can, so we can see what it's supposed to look like. What I'm going to do for people that join, I'm going to try to fit this over here so you can see, so people can see what the actual problem is later down the line. But it's going to take up so much room. Hey, it's a lot up there, but people can at least see what's going on at the top. So anyway, let's get started. So what did I say we're going to have to do? Well, if you do these problems, you learn the foundations and learn data structures and algorithms first, then you will both know this rooms that's getting passed in. They said it's a number, and it's a multi-dimensional array. That is like a 2-dimensional array. I'm sorry. Both. It's multi-dimensional. It's 2-dimensional specifically. So you need to understand what that data structure is and what it means. And we know in this case, it's, these rooms. And then you also need to know how to traverse that array different ways. And so you can just loop through it. Of course, you can loop through the rows and loop through the columns. So you can loop through this first array and then loop through each individual items array, subarray in it. But if you're doing a breadth first search, what you want to do is you want to start at a starting point, and then you want to let that point let you decide where to go next. So in our case, we want to start at a room, And then we want to look at what keys we get in the room, and then we want to let that drive, which we take those keys and go to other doors, to other rooms. And that's how we're going to traverse the array. And what that is basically a breadth first search. Like wherever you go, if this was a tree, if you get to a new node in the tree, then you may need to go to the new nodes of a tree, like leaves of a tree. Like you have a leaf of a tree, you come to a node here and you have 5 different nodes you can go to next. And then let's say you got another branch, you go to those nodes next. That's how we're going to treat the keys with the doors here. Whenever we get to a room, we're going to take those keys and then we're going to use that to tell us which door to go to next. So how you do that is what you first start off is with a queue. And you can call this whatever you want, but typically we call it a queue, or I call it a queue. And they said in the problem, they say the first door, that's all the rooms are locked except room number 0. So we're going to put 0 in our queue to start. That's where we're going to start off. That's going to be our starting point. That's our search point. That's the only door we can get into is door number 0 or room number 0. And then the next thing we're going to set up is a visited set. Now you gotta also know what a set is as well. But a set is basically a unique value. It's a data structure that holds only unique values. So when you can only put one thing in there, you can only put unique items in this set. So I know that my rooms are unique items. So I know basically I want to say, let's call this visited rooms. So I want to know when I visited all the rooms. So I'm going to use this set. When I put something in the set, I'm going to put all my unique rooms in the set. It'll be 0. In our first problem, it'll be 0 through 3. Room 0 through 3. And so I want to know, like I said, I don't want to repeat visiting a room again. So I want to be able to use a data structure to basically save. Like think of this as saving on a video game. You save which doors you went to already. That's what this visited room is going to be. This is something, it's called memoization. I don't know how you pronounce it, but in coding and data structure algorithms, coding problems, it's called memoization. It's basically using a data structure to kind of save you from doing repeated work. In this case, it's not, I guess it is saving us from doing repeated work. It's saving us from going back into rooms we already been in before. So I'm going to do that. And then I think that's all I need to set up beforehand. And so the next part of setting up like a breadth first search for doing these 2-dimensional arrays is you want to take the queue and you want to look at the length of the queue. And you want to keep the queue running as long as the length is greater than 0. Because once the queue is empty, we're done. We've did everything we're supposed to do. And so from that point, the first thing you want to do is, and what should I call? First thing you want to do is you want to pull something out of the queue. So we already put 0 in the queue up here. In JavaScript specifically, you pull something out of the queue. I'm sorry, not queue, but pull something out of the queue. Can't spell right now. God dang. Okay, queue. Spell queue. That's how you spell queue. If anybody need to know that. Use shift in JavaScript to get the first thing out of the queue. So we're gonna pull this first thing out of the queue. What are we gonna call it? So what is in the queue? The queue, what's in the queue is it's a key, right? It's a key. Cause yeah, this is 0, so this is the 0 key. So I'm gonna call this a key. I'm gonna say we pulled this key out of the queue for room 0. And room 0 was unlocked already, but let's just, for the sake of our algorithm, just say that we already had the key for it up here since it was unlocked. Let's just pretend like we had the key. We got a free key right here and we put it into the queue. And so once we have the key, the first thing we need to check is we need to say that we visited this room, because once we've kind of used this queue shift, taking this out of the queue is sort of like visiting a room. And so in that case, we want to say we visited the room. And what we do, how you do that in the set is you say add, and we can add the key and say we visited the room for this key, for this room. The key is basically the room number. So the key matches the room number. And we don't want to do that unless like I said, we don't want to go into rooms that we've already been into. So we're going to loop this, or we're going to put an if statement around it, and we're going to set it to the opposite, the negation of it. And we're going to say if visited rooms are set already has this key, then if it doesn't have the key, then we'll go into here and add the key saying we visited this room. If not, then we won't visit this room. And so then what we can do down here is just pull the new keys out. And maybe we can just call this, we call this room key or key. We can call it room key. Room key. So does this make sense? Room key. And then now we want to pull our new keys out of the room that we're currently in. So we're going to use rooms from up here. It's a multi-dimensional array. And what room are we at for the, so we know that we're at this room key. So yes, this is actually using the room key that we have right now on the room. We basically said we're in the room. Now let's get the keys in that room by accessing the room's multi-dimensional array at the index, which is our current room key. That'll give us the new keys that we have. And so from there, now we need to loop those keys, and we need to figure out what keys we got and do something with those keys. And so how you do that is you just want to set up a for loop, simple for loop. New keys dot length. Yeah, I think, yeah, it's less than dot length plus. That's how you do a for loop. And then for each, so then that would mean new key. New key is equal to, that's how we access the key, is we use, the iterator, that whatever we use in our for loop. So that'll give us each key. We had our keys, and now we just need to get each individual key out of it. And what we want to do with the keys is basically add them to the queue. So, and I think that would be push. Add the new key to the queue. So basically every time when we get to a room, we shift whatever the next room is to visit out of the queue. That's our room key. We check our visited rooms. Have we been to that room before? If so, we just skip this whole thing. We don't need to revisit the room we've been to. If not, let's go ahead and mark that we just visited this room by adding the room key to visited room set. And then after that, we can pull out of rooms using the room key. We can pull out our new keys that are in that room. And then let's loop through those new keys, and let's see that, let's get each new key and just push it into the queue, which we don't even really have to set up a extra variable for it. We can just do it like that. We really don't, it just makes it cleaner to see, but it actually is going to hurt the algorithm at the end if I keep using all these variables. But I'm going to use them just so it's clear for y'all to see, like new keys, and then we get new key is just one of the new keys because we're looping through, and then we push that key into the queue. And then once we loop back up into here, the queue is not 0 because we keep adding keys to it. And then it'll just find the next key, and it'll just work that key, and then it'll find the next key and just work that key. And once we get through this full queue, we'll get to the point where we don't have no more keys. Like we'll get to some point where we just get to there's no keys left. Or we get to the point where we visited all the rooms, and we'll just fall out of this whole loop. So we either have visited all the rooms, or we'll get to the point where there's no keys to push in. And that is basically these two cases. Like we get to this room, there's no keys, then we'll stop. And if we get here on this one, we'll get to a point where we visited all the rooms and we can just stop. And so how do we solve the problem though? The problem is asking, given the array of rooms, return true if you can visit all the rooms, or false if you can't. How do we know we visited all the rooms? If you just look at my code, how do you know that we visited all the rooms? It's pretty obvious the way I named the code. So visited rooms. This is the clue here. Basically, we know we can return true or false. We know if visited rooms, since it's a unique set of all our room keys, then if we know visited rooms dot, I think its size is a set. You kind of got to know how a set in JavaScript works, but this size property gives you the size of the set. If that is equal to the length of rooms, which that means how many, that's our variable that got passed in. How many rooms do we have? Rooms.length gives you that. If we visited as many rooms as we have, then we know we visited every room. Or you could probably say like, you maybe could say greater than or equal to, but I think in my case, it's always going to be equal because I'm always checking to make sure I don't visit a room again. It's a set. The problem constraints tell me that the keys will always be they'll always be one of the rooms. So with these constraints, I mean, I think I'm good to just set it to equal. Like there's no, and it's like always going to be unique keys in a room. So I think it's fine to just set it to equal. And usually what I do at this point, I mean, this looks good. This looks like it might work. Usually what I do at this point is in an interview, some interviewers, they're going to have a code runner like I have here to run the code. Some won't. Like I've been in interviews where they just give you like a literal notepad and make you run the code in the notepad. And then they they make you trace the code in the notepad. And I literally have to go line by line, get a test input, go line by line and test out the code to make sure it works manually. There's advantages to that. Like you could actually have it wrong, but as long as you explain it well, the interviewer probably may not know the difference if you had it, So it's kind of like they really they don't directly test that you have the right answer in that case, but they just want to test how you think and how you problem solve and how you solution and are you on the right track, and they don't really care that you got the exact right answer. Some companies do. Some companies make you run it against the compiler and against the interpreter or whatever, and it makes sure that it gets the right answer and passes all the test cases. So what I usually do on these things is I'll go through each line and make sure everything works. I'm not going to do that because I was kind of explaining that as I went. So since I can run this on LeetCode, I'm going to go ahead and run it and see if I get any errors. And I'm going to fix them if I get any errors. So yeah, I got some kind of error. Yeah, I do this every time. Switching too many languages. It's not supposed to be a semicolon on the end there. I don't know why I did that. And I think in a browser, the browser can just skips that. So yeah, I got it right as far as these two test cases. So what it's doing, LeetCode is doing is running, let me see, example 1 and example 2 from over here. LeetCode is just running those two cases. Case 1 and case 2 are just those. And it's basically saying I got true, expected true, output true, expected was true for the first one. False, expected false for the second one. So my code appears to work properly, which is great. Nearly on the first try. I had one little thing in there, and that's why I think in the interview you might want to go back to your code and trace and make sure that it's clean and that you don't have any typos and stuff like that. I'm trying to save time, and I've already over explained the code, trying to teach people, whatever. So but you might, it's good practice to do that, but at the same time, interviews are timed, so yes, sometimes you gotta, sometimes you do have to skip certain things, So just, you have to kind of make a smart decision. But anyway, I'm taking too long right now anyway. So at this point, what LeetCode also allows you to do is, I'm skipping something. See, time complexity. So in the interview, they're gonna ask you about space and time complexity, or time and space complexity. Or runtime complexity is what they might call it instead of time complexity. And so what that is big O notation. And big O notation is a way that we are able to describe the time and space complexity of an algorithm as it relates to the size of our input. And in our case, the size of our input is rooms, or our input is rooms, and the size of it is the length of the rooms. And so basically, time complexity is how many operations are happening in relation to the size of the input. So I know I'm making a queue And this queue, we're at least going to have to visit every room. So if we call the length of rooms like n, let's call it n variable, for example. That's what big O notation usually uses, is the letter n for it. I know that at least we're going to do n operations. We're going to have to put every single room in the queue at least once. We're not checking rooms again, but we're at least going to have to do it at least once. So I know at the very least it's big O of n runtime. That's going to run at least n times to check every single room for keys. And then it's going to actually check the keys in the room inside of here, like how many keys there are. And so in that case, then you're going to have even more operations. So, and it's nested inside of this. And so I believe that would mean it's going to run n times how many rooms I have times, I guess, the largest worst case. And big O notation is working off worst case. So if just say we had 1,000 rooms and then we had 1,000 keys in each room. So then in that case, it would be 1,000 times 1,000 to basically check every key, because we still have to check every key and make sure it's, not, we haven't been there before, because we don't know what other rooms we have at any given point. And so it'll be 1,000 times 1,000, which it's not exactly n times n. This number is different from n. And so the worst case, this number could be anything. So let's call it m. And so I think in this case, the time complexity would be big O of n times m, I think. I may be wrong there. Or I mean, you can call it n squared, but it's actually not n squared, because n is the length of the rooms. So you can't really call it n squared. Like, n is the length of the rooms, and this is the length of the keys, which is a whole different, even from the constraints, it's a whole different value. So, I mean, but it is constrained to 1,000. So I don't know. Since it's constrained to 1,000, it might be negligible. Like, it can never be more than 1,000, and them all added together can never be more than 3,000. So, but I'm still gonna go on a limb, and I'm just gonna say how you write that out: time complexity, big O of m times n. Or sorry, I meant to put n times m, where n is the size, the length of the rooms. How many rooms do we have? And m is worst case, the worst case of how many keys that we have, if that makes sense. It's variable because you can have different numbers, but the worst case, like let's say we had 1,000 keys in one room, because that's what the constraints say. We could have 1,000. I guess we can't have 1,000 keys in each room. So I don't know, because this problem is so constrained with the 1,000 and 3,000. If this problem didn't have any constraints on the keys in the room, then I definitely would say it's n times m. But because it has constraints on the keys in the room, I don't know. It may just be big O of n. I don't know, but I'm gonna go with big O of n times m. See, I don't know everything, so we'll see what that is. Space complexity. I do know this one pretty clearly. If I could type. Big O of n, linear time. And that's because, shoot, now I might be eating my words here, but I think that's, because, so space complexity is basically, what are you using a data structure that is scaling to the size of your input? The size of our input is m and n, because it's the length of the rooms and it's the size of the keys. The only thing I'm doing as far as a new data structure is, I guess it would be the Q, and it might be n times n too, because I got the Q that can fill up. I mean, it's possible the Q could fill up to, because I'm never putting a new key in there if it's not, I'm never putting a new key in there if I've already been there before. So I think actually it's just however many rooms I have. So I think it's just, space is just big O of n. It's how many rooms I have. That's how many things will go in the queue, and that's how many rooms I'll visit. And so I'll make a queue that's up to the size of the rooms, and I'll make a visited room set that's up to the size of the room because it's unique. Yeah, so I think it's n plus n, which reduces in big O notation down to n. I know on TikTok, appreciate that. People on Instagram commenting that same thing. Yeah, gotcha. Lino made something. Yeah. Okay. Yeah. So I think that's what I'm gonna go with. I'm gonna go with big O N for the space and big O N times M. I may be wrong here. So the last thing I'm gonna do is I can run this against LeetCode, against all other submissions on LeetCode. All of the test cases on LeetCode. They ran it against 2 to start, and then I can run it against these more strenuous test cases and way more test cases. And it'll compare it to other people that have done this problem on LeetCode. And it'll let me know if there's something wrong with my algorithm too. Like if it just doesn't work. So yeah, it worked. So I only beat 29%, but I'll take that with a grain of salt. Like if I ran this, like let me submit it again and see if it changes. Yeah, see now I got 73%, which is, it's weird. So anyway, I don't know, because I got 90% on memory before and now I got 72%. So it's just kind of weird. But anyway, it basically means my problem fully passed as far as LeetCode standards are concerned. Passed all these different test cases. Let's see what they think the runtime complexity. I can only use this twice per day. Yep, N times M. Oh, my bad, y'all. N times M. So I was right on that because I was definitely guessing. I really didn't know, but it's N times M. At least as far as LeetCode. This ain't perfect, but I'm pretty sure if LeetCode found it's N times M, then I'm pretty sure it's M times. I mean, they made the problem, so. But this is supposed to be like AI that's doing this, so. And yeah, it's linear. Big O N for the space complexity. So it looks like I got all that right. And yeah. Looks like it is looks like we good to go on that. So let me slide this back over here. I appreciate everybody watching. That's basically the problem. It's called keys and rooms. Just to go do a little recap, it's called keys and rooms. Basically, you're given a list of rooms, and the rooms have keys in them, and you stop by every room that you get a keys out, and then you go and unlock other rooms and see if you can get to all the rooms by the end of the problem and return true if you can and return false if you can't. And over here is the problem again, the problem definition again, and then the code. And for a medium problem, this ain't much code. Like, I think if somebody asks this in an interview, it is a more tough problem, I think. Then it's not an easy for sure in an interview to ask. But like if you're a mid-level senior dev, they might ask this. I don't know. A lot of times they just go straight to a hard problem, or they'll do an easy one up front and then throw a medium one behind it, like build upon it. But you might get this one. And I like it. It's like a great entry level to doing like grid problems, matrix problems. And somebody said OG watches. He said it's tough when you're nervous. Yeah, man, these interviews, man. When you could do all the preparation, but if you get too nervous in the interviews, it'll just kill you. And like you just have to get to. What I had to do is I just had to start taking in. I took like some practice interviews, I'd say, where it was like if I got the offer, I'd be happy. But I was kind of like in my mind, I just put in my mind like I'm not here to pass the interview. I'm just here to get practice and get comfortable being in interviews, because that's a whole nother beast. Just being in there and not letting when they sit down and they say hey and you start talking to them and then they put that problem up there and it's just an empty blank slate and you got to figure out. It's like worse than a test in school. You like when you're in high school, college, sit down, you get the test, they put it in front of you, it's a question in a blank space. You're like, man, I'm nervous, I gotta pass this test. It's worse than that because you got a person sitting there watching you, expecting you to talk about what you're gonna do. And in school, if you don't know the answer, you could just skip the problem and just not be embarrassed. But in an interview, you gotta sit there and eat that junk. If you don't know, if you just blank, and so it is nerve wracking, man. That's a good point. It's nerve wracking. So it's something you almost have to try to prepare for. Fail every damn day. He said, appreciate the knowledge. Hey, I appreciate you jumping on and watching. So Somebody said, wouldn't it be big O of N plus K? Yeah, basically big O of N plus K or big O of N plus M, whatever you want to call your variables or what it would be. So, but you're absolutely right. Fail every damn day said the same thing. And let me see if I got some comments. Yeah, I'll just answer a couple questions for now. I appreciate y'all joining and watching me go through this coding challenge. I do these every Friday. I'm on all channels on Instagram, TikTok, Facebook, Twitch, YouTube, TikTok, if I didn't say that. Everything. I'm on all these, Twitter too, X or Twitter. I'm streaming live every Friday doing these coding challenges, usually around from like 6 to 8 to 9. I don't know. I do it in the evening whenever I get ready. And so follow me if you want more content. Follow each other if you find each other in the chat. Like just trying to build up this, build up a community. They're trying to get good at these. I don't like these problems. Like I don't think we should be interviewing like this. Honestly, I don't think these companies should be interviewing like this. They make me interview like this on my job. And when I go to search for other jobs, I got to interview like this. This is the reality. And so I choose. A long time I was resistant to doing these kind of interviews. And one day I just said, I'm not going to let that stop me from being able to get certain jobs. I'm not going to let it be this thing in my career that I can't beat. And I just buckled down and just studied it it took me like maybe 3 months to get to interview shape. And I wouldn't say I'm even perfect now. Like I got a lot to learn. But I did get to the point where I was able to pass a lot of interviews. I failed a lot of interviews too, but I was able to pass a lot of interviews. I passed some at least one FANG interview and a few big company interviews that like non-FANG but like still huge companies. And I was super proud of myself. Like I'm super humble, but at the same time it was like that junk was hard. Like it was like one of the hardest things I ever did in my life to like study this stuff and get to a point where I could pass an interview and like, just eating those failed interviews when they call and say, you didn't get it because of your interview. It's hard. It's hard mentally, physically, everything. So, anybody that's in this journey trying to learn this stuff, like just keep going. It gets easier. And like you eventually get to a point where you start to see the patterns and the problems. And you start to be able to do like do pattern recognition. So like with this problem, I did this earlier tonight. Like I ain't ready to just be jumping on here just blank. Like anything I do on here, I either done it the same day or the night or like a week ahead of time or whatever. Like I'm not just gonna come on here. Maybe I'll do that one day. I just come on here and blank out. But like really, what I want to do is like just remember the patterns and the problems and like be able to explain it to people. And so y'all helping me be able to explain it because you got to be able to explain it to an interviewer. And so but anyway, this get easier once you like learn the data structures, you get them down packed, you learn the algorithms and get those down packed. So like this type of algorithm, you shouldn't be able to do this. You shouldn't have to memorize this problem. Like don't memorize problems. But what I memorized here, this is before I ever done this problem. This is the first time I seen this problem was today. But I memorized how to do breadth first search against a multidimensional array. You need to know that algorithm like the back of your hand. And what'll happen is most of these problems are or these problems that follow this pattern, or they will have some derivative or whatever of breadth first search. Like you might instead of just storing a number in here, you might store a whole object in here. And instead of, adding the new keys back to the queue, you may add you may be looking at a grid and you may, a grid, when you're in a grid and you're in a cell in a grid, you got a top thing, you got a side, you got two things on the side, you got one thing on the bottom. When you're searching in that grid and you need to search the next items in the grid, you need to search the top, you need to search the left, the right, and the bottom. I probably got the left and right wrong, but you know what I mean. And so in that case, that would be your new key, would be like the next cell over or the next cell up or the next cell down. And so like knowing how to do this algorithm and kind of adapt it to different problems, but knowing the algorithm first is you can't get stuck on the algorithm in the interview. You may get stuck on trying to adapt it to the problem, but you don't want to get stuck on the core algorithm. So people recommend Algo Expert a lot. Neat code is one people recommend a lot for, having a shorter list of problems to learn for best return on investment. But I recommend neat code for when you're trying to get back in interview shape after you've already learned basic data structures and algorithms. For learning basic data structures and algorithms, I recommend, and I can pull it up, I think, and y'all kind of seeing my business, but it's called Algo Monster. I don't know why it's giving me this survey, but it's called Algo Monster. And basically what they do is they give you and if you've been on my calls before, you've seen me bring up Algo Monster. I don't get no money from Algo Monster, but Algo Monster literally helped me learn the basics and pattern recognition. They have the top patterns that they've seen in top interviews. It's not all interviews, but it's like the big company interviews. Mostly it skews that way. And these are all the patterns: two-pointer, heap, graph, dynamic programming, DFS, which is depth first search, BFS, which is breadth first search. That's the problem. That's the pattern I did tonight. And being able to recognize this pattern in this problem. Once I read this problem and I noticed it was a multi-dimensional array and I needed to kind of like traverse through it, I knew that I was going to need some breadth first search, and I just need to figure out how to adapt it. And so they teach you they're going to teach you the basics of these patterns first, how to code these patterns. They're algorithms too. And they're going to basically give you, that's the only part you really need to memorize, is memorize the algorithms tied to these problems and memorize the prompts for these problems. Cause like it's kind of a game, but this is the way they made it. This is the way they interview us. And so you kind of will read this problem and being able to recognize how it's like what it's asking you to do and tie that to one of these patterns. That's the easiest way to get good at this stuff. Really learn these patterns, really learn the algorithms that go along with them. They're really small algorithms. Like this one I just did it's not a crazy algorithm. And all of them are pretty short. Now the problem is when they get hard, they get longer, but the patterns are the same. And so that's why I recommend Algo Monster, because it definitely changed the game for me and getting better at these problems. So no, I'm just rambling with that, but I'm hoping that'll help somebody. I know it's reiteration for a lot of people, but everybody's at different levels. You know how I go. BFS and DFS is baby steps. You need advanced algos. MST, shortest path, back propagation. Yeah, that's when you start getting into the hard level problems, like where you start, dynamic programming, where you end up like sometimes piecing together, multiple different algorithms, and like, yeah, it can get pretty difficult. Like, I feel like when I was doing interviews, the hard problems they asked mostly were matrix problems. Like Airbnb, it was just this big matrix problem with depth first search. Like it was kind of similar, like a harder version of this. It had like keys and doors, and you had to go find the keys and then go open the doors and backtrack. You had to do backtracking. So it like combined a lot of stuff. It was breadth first search, and then you would like, instead of what I'm doing is going through these doors in this problem, you would like go through this maze and it had walls, and you had to like find the key and then backtrack and go and find the door and go through the door and get to like the cheese or something, like a mouse. And that had backtracking, depth first search, breadth first search, and I think it had like memorization, like, cause you need to know where you already been. And it's just a lot of store the key that you have. Like it was a lot of it was a lot going on with that problem. But yeah, it gets a lot more complicated. For sure. So, let's see. Scared, what would I do if I lost my job? Oh man, yeah. Shoot, I got real comfortable, man. I was in a job probably like 7 years before I started even looking at this stuff. I refused for 7 years. I was just like, I'm not going to companies that interview like this. But eventually I just said, man, I'm not going to let this be some kind of handicap for me. And I'm not the best at it, man. I don't know all the stuff, honestly. Like, honestly, what I do is whenever I have a big interview, You can find, like, it's crazy. You can find a lot of the answers on blind.com or the Blind app, if you ever heard of that. Glassdoor, LeetCode, Premium. You use all three of those for the and your if the company's big enough, one of the bigger tech companies, they will it works, man. It give you a good idea of the types of problems they're gonna have on the interview, and then you study those types of problems. Like, don't just go trying to do the hardest problem ever you can find. Like, it's not gonna serve you well. Like, you need to do. And LeetCode has, once you get premium, I stopped. I don't have premium right now, but when I'm interviewing, I have premium, and so actively interviewing, I have premium, and so it has the companies, and you can sort by companies by the level of it shows up, how many times the problem shows up. It's not perfect, but man, that thing is good. It was good. I ain't even gonna lie, and I know I'm getting a little weird excited about it, but that junk saved me. Like, now the problems weren't exactly the same, but it was like they would like just change little things about it, but like the core fundamentals of the problem would be the same, and then I just adapted to whatever the little change that they have. And like, I mean, this is for Amazon, this is for Airbnb. Like, the Airbnb problem I talked about was on LeetCode. Like, it works. It was on Glassdoor, on one of these sites. Like, it's there. So, and look on Blind, like blind.com. People, you can ask yourself, and people are asking on there, hey, I got a SDE2 interview coming up. What type of stuff should I be studying? What type of problems? And somebody will come in there and tell you. And so, yeah, that's kind of how you can scale down the problems versus just trying to be like, let me just cover every single thing. It's just not, you're going to waste a lot of time doing that. You need to focus on return on investment. Because you can be studying this stuff for years, and if you don't study the right thing, and they get you got one shot, and you mess up one. A lot of these companies is so competitive now. If you mess up one problem, usually if I messed up like one problem, I didn't get past my last interview run, and this was a while back. So now I think it's probably even more competitive, and so I hate to kind of scare, but I mean, maybe it was the level of companies I was interviewing for, but it was. I'm not saying I didn't make no mistakes in the ones I passed, but I'd say I felt really good when I got out the interviews of the ones I actually got an offer for. Like, I didn't have any bombs on it, so, and yeah, so it's tough, man. But, some companies got a lot more leeway. Maybe I just got unlucky, so it is what it is. But, yeah. But you learn so much from all the experience. Yeah, exactly. Bombing those, man. And so don't let nobody get on this internet and tell you that they don't bomb interviews. Fail every damn day is what he just said. Like, those bombing those interviews is when you learn a lot. Like, that's when you learn the most, I think. Like, because you go and look at that problem and it really sticks because you like, dang, I could have did this and that. And so a lot of times people, they pass interviews because they bombed interviews. And they just get to the point where they bombed enough to where it's like they just seen the stuff already. And so it's unfortunate. So you got to give yourself time to go through some interviews, to go through some failures. It's going to hurt. It sucks every time. Like, especially when you get senior and you feel like, man, I could really contribute to this company, but you just failed the interview. Like, I was senior last time I was interviewing, and I was like failing interviews, and I'm just like, damn, it's a hit to your pride. It's a hit to your, gives you imposter syndrome. Like, it make you feel bad. But then once you hit some and you pass them and you just get through, and like, you just like, damn, like, I can't believe I did that, Well, that's how I was, I guess there's probably some devs out here that's like super confident, but these folks out here failing interviews too. They just don't tell nobody. They just too embarrassed to tell people, but they out here failing interviews too. Because people, I mean, when we hire this one slot, we might interview 5 people and there's one slot. So even there could be 3 good people and still people fail, because we have to find the most minute reasons to fail them. So, don't let nobody tell you that they ain't failing interviews, especially not these tech interviews with these hard, ridiculous LeetCode problems. Which, yeah, so I'm on here doing them, but I mean, I don't necessarily agree with the philosophy of asking them, but I do see value in them as far as helping devs to optimize their algorithms and optimize their code. I have seen in real life application on the job where bad algorithms have cost companies money. They've made servers go down. They've ate up too much RAM on machines, and cause servers to go down, or cause servers to have to horizontally scale unnecessarily, or be vertically scaled that costs more money. I've seen them take down, have just stutter because of too many requests and just handling the requests too slow. Like, the space and time complexity does matter in certain applications. Now, sometimes you might get on certain jobs where it just don't matter. It just really don't matter as much. But in some jobs you get on it where that's all that matters. And so it just depends. So it is valuable, but the way they gamify it, I just don't. I wish it was just a little bit more applicable to the job. But there's a lot of jobs that's starting to change from leak code problems. They're like, when last time I was interviewing, was a lot of them. I was doing like JavaScript roles, and they were doing a lot of like build this UI component, which I thought were cool problems, and it would have kind of like a algorithm behind it, but it wasn't like these gamified, like they don't nothing to do with anything problems, like key in a door, fake door type thing, where it loosely connects to some sort of real world thing, So anyway, are you able to code on emulators? Code on emulators? That's I don't know what you mean exactly. Code on emulators. You mean like game emulators? Like, it's game emulators. There's an iOS simulator or emulator. I code apps. I make apps. That's some of my content I share on here, is making mobile apps, which I use the simulator, which is, I guess, a form of an emulator. But yeah, I haven't done any, like, are you talking about like ROMs and video game emulators? I haven't done anything like that. I could, but I haven't really been into video games. I don't really want to ruin it. Do you have a Twitch? Yeah, I'm streaming on Twitch right now. So if you want to go on Twitch and watch me there, you can do that for sure. I'm on every platform almost, like, and I'm streaming like all at the same time. So you can jump on there. See if there's any more questions. Any that I want to answer. Do you have a Twitch? I already answered that. I interviewed for Roblox one. You literally have to play video games as part of their process. Was it cool though, or was it like kind of stupid? That seemed cool. From how you putting it, like, unless they ruined it. That's the only thing. It's like, I feel like making video games for a living, it could kind of hurt I guess if you're not working on all the games that you play, I guess it don't really matter, but I don't know. I feel like it could just I feel like it's hard because of the deadlines. Video games have these tight deadlines that's like, and so you end up working like really hard, like before deadlines, like working like weekends and late nights. And it's like a hard industry to work in, I feel like, because of that. But that's just what I've heard. I don't know for sure. It is what it is. Oh, and Android emulators. But like make a bot for Android emulators? I don't think I've done nothing like that. I could learn how to do it for sure. I just don't think I have. I've been doing mostly at work. I do mostly like web development and like UI, like JavaScript, web development, basically. Web application development. And I do mobile app development kind of on the side. Well, definitely on the side. And then I do full stack. I'm full stack. So I do services and all kind of stuff. Make databases. 5 steps. The interview for Roblox had a online assessment, 2 video game rounds, behavioral, and then on-site. What were the video game rounds though? What did you have to do? Like, did you have to code in them, or you just literally just played Roblox? And then the behavior, I know what that is. On-site, I'm guessing maybe in the on-site they maybe asked you some coding challenges, or maybe it was just to meet you. That don't seem like a bad process though to me. How you putting it? Any advice for a new dev? Can't find a position to save my life. I mean, I would need more details. Like anybody that has questions could DM me too, so I can like ask you for more details and give you more crafted answer. But I mean, it depends on why you're not getting the job. Are you not getting callbacks for interviews? Then I would ask how many applications are you filling out. I would ask what your resume looks like. I would ask what your experience look like. Well, if you say you're a new dev, so I would kind of see what your resume looks like and see how maybe what you could do to add something or what you could change. If you're getting callbacks but then failing the interview, then that's a whole different problem that you can tackle from a different area, because then you need to kind of try to gather more feedback to why you're failing. Like sometimes they don't give you any feedback, but people always say they're like, I didn't get no feedback. I don't know why. Like, you know when you didn't get a problem right. Like you kind of know, right? Like you know how the interviewer responds. You know when you can't finish a problem. Like it's sad, but in these tech interviews, like if you just basically just bomb a problem, like now if you don't get to the right answer but y'all had a good discussion, then there's a chance you might get hired. But if you just bomb a problem and they have to just stop, just expect that you just go ahead and expect in your mind you're not gonna get it, and that you might be luckily surprised, but just expect you're not gonna get it. And so those are the kind of questions I would ask. Or if like you're putting in a lot of applications and you're not getting any callbacks, then it could be indicative of just the industry and not having enough jobs out there, which that's just like a hard problem to solve. Like it's just, I think in that case, networking is the only solution. You know, actually getting out. Like I went to Render ATL. A couple months ago. Big networking opportunity, getting to know people, walking up to people, talking to people, finding them on their social media, like building genuine relationships with people. I ended up building a lot of relationships on there. And so it ended up helping me like get opportunities. And I think in that case, when you just, the industry is like it is right now and you can't find jobs, I know it's not great advice, but it's like the only other option you got. If you're literally putting in 100 applications, you be putting in a lot of applications now. You know what I'm saying? Don't think you can just put in 10 applications and then think you just, like when I was, even like 10 years ago, when I was putting in applications, I mean, it was like 50 a day, sometimes 100. Like I was going crazy, you know what I mean? So, hey, I was joining every single site possible. I was putting in applications, multiple sites from different to the same job from multiple job sites if I could. Like I went crazy. So, I mean, just make sure you're working, to that urgency too. Don't think just put in 10 and you think you got, 2 out of 10 chance. Like you got to put in a lot. So yeah, Aaron, appreciate the question, man. That's a great question. Just trying to see somebody, KFC on YouTube, say, hey, what's up, bro? What's up, dude? Let me see if anything else I want to answer before I jump off. We just had a hurricane come through Georgia, so probably get off here, get some sleep. Got to do some cleanup stuff tomorrow. What does your LinkedIn look like? I ain't updated in a while because I ain't been looking for a job in a little while now. But I mean, I think it looks pretty good. I'm Kelvin. I mean, you can look on my channel and get my name off of there. Or my whatever site you're watching on. Just get my name. You can go look up my LinkedIn, add me, and check it out. I think it's pretty good. It gets hits. I get DMs and stuff. But I mean, see, I'm more senior because I've been in the industry for a long time, so it's a little easier for me to get hits. The job industry definitely ain't moving like it was, because I used to get hit up by Facebook, not Instagram, Facebook, of course, Meta, whatever, Amazon, a lot of these other smaller big tech companies, but like not those huge ones. Shoot. I mean, all of them to some, Microsoft, like all of them to some degree, like back when it was like hot during the pandemic, they all used to be hitting me up, man. But now it's like, yeah, they ain't moving like they was. Like they trying to get people to return to office and all this weird stuff. And like they ain't sending out stuff like they used to be, for me at least. Or maybe I ain't been looking, but it ain't been as prevalent as it was. And so, yeah. And it was some of those companies I almost went to, but yeah, it just didn't work out. So but it worked out for the best. Let's see. How many applications should I do in a day? I mean, it depends on how many applications you're able to find, but I mean, if you can find like 50 applications, I know this sounds crazy, but like I would say until you start to like tap out of applications you can find, like I would say at least like 50, like, you know what I mean? Because after you do, so let's say you take 3 days and you just do 50 applications those 3 days, and then you start to run out of ones you can find, then you've got that big body of work out the way. Now you can just start studying and just waiting for people to hit you back. Because sometimes it takes weeks and months, and sometimes it takes a long time for them to start actually hitting you back. Because these people in these companies are busy. I know when we start to interview people, it takes weeks to just start interviewing people. Like after we put out the call. So, and a lot of people don't have time to wait. They got bills to pay. They ain't got time. And so just as early as possible, just start putting out, if you're ready to interview, right? Like you got to be ready. But like, and even if you're not ready, if you just want to get some practice was in, if you don't care that you lose, it just depends on what you sit and kind of what your kind of, I guess, goal currently is. But I know 50 sound crazy, man. And maybe not exactly 50, but you should be doing like a lot, man. Like not just 10, not just 20. Like if you got the time, like you should be at least putting in like 30 of them. I mean, because some of these sites, you look at LinkedIn, they got one-click apply. You know what I mean? Like a lot, and some of these job sites, you go fill out the thing first, and then you just do like a one-click apply. So it's not like I'm asking for something like insane here. If the jobs are there, then you should be going crazy on the applications. Like, because I think people kind of think that it's like if you qualified, you're just going to get an interview and these people just not calling you. It's a numbers game. It's a lot of luck involved in getting hired, and it's no way around it. Like we think we got more control over it than we do. I've been a manager before and I've hired people, and it's luck because it's timing. It's like when your resume comes through, it's timing. It's like my bad time. Like I might have something busy at work, so I might just skip over certain people that came in, and then by the time I try to hit them up, they already got a job. It's a lot of time and stuff, you know what I mean? Or sometimes, you just a little bit too late. We just happened to hire the person, and you were the better candidate, but you just entered your thing in a little bit too late. And so it's a lot of timing and luck that goes along. And, you can call luck what you want to call it, based on your beliefs. But, it's a lot of, you have less control over it than you think. You think just because you got a great resume, you got a lot of experience that you just shoe in for a job. But even the jobs you get, once you get the interview, then yeah, now you got, you got something more to stand on. But getting that interview ain't always, you increase your chances by having more experience and a better resume. I'm not saying that, but I'm just saying that it's still a big amount of luck, more than people kind of care to admit with it. So it's a numbers game. Put out a lot of a lot of applications. So that's all. That's why I'm saying all that stuff. But I got to see interview questions now that I've been there for a while. Oh, cool. I think Stephanie, what were you saying? My current job, the interviewer was on PTO during my interview. My current job, the interviewer was on PTO during my interview. Oh, dang. So they came and did your interview while they was on PTO? But see, that's how it's crazy the scheduling can get, because sometimes they push us to interview people because they know that y'all may like in a week, y'all may be off the market. And so that timing, man, can be crazy. Like that's why a lot of people do this thing where they try to like line up their interviews at the same time so they can get multiple competing offers and then make them kind of bid on you a little bit. But it's hard to time it up though. I mean, I tried to do it before. It was kind of hard. No, he wasn't there, so someone else did it and they didn't ask the technical question. Dang, you got lucky. See, that's what I'm talking about though. Y'all hear what I'm talking about? So it's like, look, this dude, he got an interview. He didn't have to ask. He didn't get no technical questions because his interview was on PTO, and then he's at the job now. Thanks for sharing that. That's what I'm talking about, man. Like, we just got a little. I know it sounds stupid. It sounds sad, stupid, whatever. But I know because I hire people, and it's just a little less control than you actually think, so you have to do everything in your power to up your chances of getting the interview, passing the interview, and being timely with it. Like, you know what I'm saying? You just have to. And so putting out as many resumes as possible helps your chances of landing an interview. It's just a numbers game. Like, you can't just be so selective. Like, I'm only going to put in an interview here at Delta. Or I'm only going to put in an interview here at Airbnb. I'm only going to put an interview here at Stripe or whatever. Like, you can do that if you want. If you really do want just to go to this certain company, and you got the clout and you got the interview, yeah, it works. You can do it. But if you really just trying to find your first job and get your foot in the door, then spread that thing out, man. With better lack of expression, you know what I'm saying? I shouldn't have said it like that though, for sure. But you know what I'm talking about. Like, go ahead and open up the search for sure. So anyway, what's this question number? This one is 841. So 841 keys in rooms. It's a good one to do for sure. It'll help you learn. It'll help you reinforce like doing breadth first search, or it'll teach you about it. So I never even looked at the solution, so I don't know. Oh, they don't have, do they have, yeah, editorial. Approach number 1 is depth first search. So you could do depth first search. Oh, this is the only approach they got on here. Depth first search using a stack. This is actually pretty cool. It's like similar to what I was doing, but just using a stack and doing like a depth first search. I guess it don't really matter what kind of search you do, because you need to go through the keys in the same way. So you don't have to do a breadth first search. Pretty cool. See, I didn't even know that. I went straight for breadth first search. But yeah, you could use depth first search here too. And it looks like that's what they kind of want you to use. Lead code. So that's interesting. Yeah. So yeah, this is how this goes. Hope you held up in the hurricane. Yeah, appreciate it. Yeah, you're in Carolina. You probably got hit harder than me. Atlanta wasn't too bad, actually, except for the flooding. The flooding was crazy. But I didn't get hit too bad, luckily or fortunately. So, yeah. Job market has been bone dry for big tech. Yeah, man. It feels like they ain't been hitting up nobody. But I get it. Like, if Amazon's returning to office, then that means they actually kind of trying to get rid of people on the low. Like, they actually kind of silently trying to get rid of people. They know certain people ain't going to return to the office. It's an easy way to reduce the workforce without having to pay severance, making people just kind of quit on their own. So they're not going to just be hiring. Now, I think even on the tail end of that, when people quit, there will be some backfill roles opening up, but it won't be like a full hiring blast. But I think a lot of backfill roles will open up, but it will be more for senior roles, because it'll be like some senior dude left, or some engineer manager left, some principal product manager leaves, where they literally have to backfill this position because it's higher up, and so they need like somebody to manage a team, and they don't have nobody, so they'll backfill those roles. But as far as like doing these massive hiring blasts to grow the size of the company, they probably not gonna be doing that, at least for I don't know when it's coming back. Like, I'm not gonna pretend to. My boy Whittington on here, he's on whatever platform you're on. He's on everything. He had said it in a video a couple days ago. He was like, all these people get online and they try to tell you when the tech jobs are coming back, and he's like, everybody's just pulling out their butt. So I ain't gonna do it. I ain't gonna try to pull no answer out. I ain't gonna try to guess. I don't know when it's coming back. So I'm gonna just try to keep my head down and make the moves I can. But yeah, it ain't a pretty market like it was. So I'm glad I made some moves during the pandemic when the market was crazy. I made some moves, and I'm glad I did. Now in retrospect, at the time it was scary. In retrospect, I'm glad I did something, because shoot, ain't nothing to do now much. So hard to make moves now. It's in the company's hands. We at their will more or less right now. But it'll. I think it'll turn around one day. I just don't know when. So I will say that. But anyway, if you have a CS degree, you don't need to be a software engineer. I work in HPC, and it's great. Cool. Why no Python? Why no Python? I work with JavaScript mostly every day. In my day job, my personal stuff I use a lot. I'm just been using a lot of JavaScript right now. So it's the strongest language I am with interviewing. So that's what I'm using. So yeah, I think I'm gonna probably hop off of here now. Like is it worth still going for a CS degree? Absolutely. Like, don't let nobody tell you that a CS degree isn't worth it. Like, it still is. A lot of companies still look at having a degree as a kind of a bonus to your resume. They really do. Some of them, like, it's a hard rule. Like, you got to have some sort of bachelor's degree at least. And so don't let nobody tell you a CS degree is useless. Now you can get into the industry through boot camps and through self-teaching. You can, but the CS degree is still a surefire way to put yourself in a great position to get a job. It really, I'm not going to just keep saying it's the best, but it's really good way. And also, like, it depends on how you learn. Like, if you ain't self-motivated, then you probably the degree is probably the best way to motivate you, I'd say, from external factors. You have classes you need to go to. You wasting money if you don't go to class. If you fail class, you wasting money. You got tuition to pay. You got professors that's pushing you along. You're being tested. You have a curriculum. Self-taught is free and you can control it, but there's a drawback because if you not self-motivated, then you're gonna fail miserably. You're gonna not know what to learn. It's new stuff coming out every day. You're gonna be feeling like you don't know what to learn. You're gonna be feeling scared, like you're learning the wrong things. It's hard to self-teach. I have people in my DMs every day. I ain't gonna say every day. I'm tripping. But like a lot, like every week at least, asking about what should I be learning. And like, so self-teaching, it's great, but it also has its drawbacks, just like college and CS degree has its drawbacks. And so, I think they're all great options, but pick the one that's best for you. And don't try to down, like a lot of people out here trying to down CS degrees and down going to school. I don't think that's makes any sense. So, yeah, thanks for that question. I just meant in the context of the job market being bad, SWE is tough. If you have a CS degree, you don't need to be. I guess you saying that, like, if you have a CS degree and the job market's bad and you can't find a job, then you can kind of go into something else. Yeah, that's true. You can go into I don't know what HPC is though, but you can go into something else for sure, like a different part of tech or some other field to hold you over until like the tech stuff starts coming back. I get what you're saying. Yeah, thanks, Driss. Thanks for the question, dude. Like, I appreciate that. Hope it helps somebody. Helps me, man, and think through this stuff. Chris says job market is cooked. Yeah, thoughts on Rust? I don't really have no strong opinion on Rust, like the language or whatever. I really don't have no opinion. I haven't used it, so I don't have no strong opinion. I do think all languages have their purposes, and I don't really hate on languages too much. So, yeah. Anyway. Yeah, K Hayes said Friday night grind. Let's go. Yeah, I'm kind of about done with I kind of been on here probably like over an hour now, but I appreciate you jumping on, dude, as always. But I'm probably I'm probably about to call it quits in a little bit here. I appreciate everybody jumping on here. Appreciate the comments. Like, go find each other, follow each other. Follow me if you want more content like this. I do these every Friday. I'm on all platforms, streaming live and posting content, funny content, informational content, coding stuff, software development stuff, general tech stuff. Follow each other. DM me if you have questions about anything or if you just want to talk about random stuff with this, related to this stuff. And I appreciate y'all joining. Like, I'm going to be back on here next week. So I appreciate it. I'm gonna go ahead and hop off and hope y'all have a good night or evening.